Good day everyone, I am Alhambra Vidal and for today's video, I am assigned to discuss the introduction to group theory. Aims. At the end of the discussion, the students are expected to know what is group theory and to know what are the properties of a group. Material used. Microsoft PowerPoint for PowerPoint presentation. Okay, but before we proceed to our discussion, let's have first a quiz map. Number 1. It is a collection of elements or objects that are consolidated together to perform some operation on them. What is the answer? A. Group. B. Set. C. Collectives. If you answer group, then you're correct. Okay, let's proceed to question number 2. It is the study of a set of elements present in a group in math. What is this? A. A group set. B. Collective theory. C. Group theory. If you answer group theory, you're correct. Okay, let's proceed to our class discussion. To be start with, what defines a group? Do you have any idea what defines a group? A group is defined as a set provided with binary operations that combine any two elements to form a third element by satisfying three conditions called group axioms. They are associativity, identity, and invertibility. Definition of a group. A group is a collection of elements or objects that are consolidated together to perform some operation on them. A group is a set of elements and an operation star denoted by G star that follows the following properties. The following properties are closure property, associative property, existence of an identity element, and existence of inverse element. The first one is closure property. What is closure property? A closure property states that when any two real numbers are solved using any arithmetic operation, the result will also be a real number. This property is applicable under the addition and multiplication of natural numbers, whole numbers, integers, and rational numbers. For every element A and B in G, A star B is in G. That is our definition of understanding of the closure property. If you have two elements from G and you applied our operation on those two elements, the result is also in G. Then you will say that the operation is closed on that set. Next is associative property. The associative property is a core concept in mathematics that shows property of some binary actions. In propositional logic, associativity is valid rule of replacement for expressions in logical proofs. According to the associative property, you can add or multiply regardless of how the numbers are grouped. For any three elements of G, this is true. That symbol there, that means for all, or every. Our understanding here will be applied to the operation first on A, B, and then we will apply the operation on the result of this and this. If this result is also equal to this, wherein we change the grouping of our operation, then we shall conclude that the operation is associative in this set G. Okay, the next one is existence of an identity element. In mathematics, an identity element or neutral element is a special type of element of a set with respect to a binary operation in that set. which leaves any element of the set unchanged when combined with it. There is an element E in G, so there is an identity element in G such that for any element of G or any A in G, E star A is equal to A star E, and that is equal to a something like this happen in a set of real numbers when we are working with addition, and you know that the identity element in the set of a real numbers for addition is 0, because any real number added to 0 is equal to the real number itself. So, the set of real numbers under the operation of addition is an example of a group. Okay, and the last one is existence of inverse element. A set has the inverse property under the particular operation if every element of the set has an inverse. An inverse of an element is another element in the set that, when combined on the right or the left through the operation, always gives the identity element as the result. Okay, and the last one is existence of inverse element. A set has the inverse property under the particular operation if every element of the set has an inverse. An inverse of an element is another element in the set that, when combined on the right or the left through the operation, always gives the identity element as the result. Okay, for all elements of G or for any elements of G, there is an A inverse in G. That is our symbol for the inverse element. We should not interpret as 1 over A because this interpretation is true only when we are working on multiplication. For each element of G, there is an inverse element in G such that A star A is equal to E. Something like this happen again in the set of real numbers under the operation of addition. Symmetry groups. What do you mean by symmetry group? The symmetric group on a finite set is a group whose elements are all bijective functions from 2 and whose group operation is that function composition. For finite set, permulation and bijective functions refer to the same operation, namely rearrangement. By definition, the symmetric group on a set is a group consisting of all bijections of the set, all one-to-one and onto functions, from the set to itself with the function composition as a group operation. Next is permutation group. What is permutation group? In mathematics, a permutation group is a group G whose elements are permutation of given set M and whose group operation is composition of permutation in G, which are true of as bijective functions from the set M to itself. A group whose elements are permutation and in which the product of the permutation is permutation whose effect is the same as the successive application of the first two. Lastly, we have wallpaper group. What is wallpaper group? A wallpaper is a mathematical object we imagine covering a whole Euclidean plane by repeating a motif indefinitely, in manner that certain isometries keep the drawing unchanged. To given wallpaper, there corresponds a group of such congruent transformations with functions compositions as the group operation. Thus, a wallpaper group or plane symmetry group or plane crystallographic group is a mathematical classification of a two-dimensional repetitive pattern based on the symmetries in the pattern. Such patterns occur frequently in architecture and decorative art, especially in textiles, tessellations, and tiles as well as wallpaper. And that would be all. Thank you, everyone.